This is Module 12 of the Linux Essential course entitled Understanding Computer Hardware. And this identifying hardware and viewing CPU. The motherboard or system board is the main hardware board in the computer to which the central processing unit, the RAM, the ROM, hard drive, and other interfaces and other components are all connected. Depending on the computer type, say a laptop or desktop or a server, some devices such as processors and RAMs are attached directly to the motherboard or are built-ins, okay, components in the motherboard, while other devices such as add-on cards are connected via a bus um, example or interface slot like a PCI or an ISA slot. There are two also things to take note in the motherboard is that there are compatibility issues. There's like this motherboard that works only for um, say Intel processors, and there are also motherboards that are for AMD type of a processor. Of course, there are motherboards for phones, for laptops, and for desktop. A central processing unit, CPU, or processor or microprocessor is one of the most critical hardware components of a computer. The processor is the brain of the computer. This is where the execution of code takes place and where most calculations are done. It is directly connected to the motherboard, um, as motherboards are typically configured to work with specific types of processors. So if a hardware system has more than one processor, the system is referred to as a multiprocessor. You've learned this in your PC hardware troubleshooting, also in your COA, that we have this term multi-core. By definition, it is a single physical chip where you have multiple uh, processors inside. So the function of the processors nowadays are in sort software based. We also have some features for the processor like multi-threading or hyper-threading like in Intel. And these are features where processor can be able to perform multiple tasks at the same time. Um, there are also what we call as um, turbo or overclocking. So processor can go beyond in its clock speed. We do know that one major specs of processors are is this clock speed, which is measured in terms of hertz. So there are two popular processors in the market. We have Intel, we have AMD. For Intel, there's like this Evolution, and then Intel also has put up a trademark for their processors. Nowadays, popular trademark is generation, right? We call it as generation, say third, fourth, fifth generation, seventh generation, so on and so forth. Intel again, in the Evolution, it originated at the x86 family of processors. This is in 1978 with the release of the 8086 processor, and since that time, Intel has produced many other processors that are improvements to the original 8086. Okay, like 8386, 8088, so on and so forth. In addition to Intel, other companies that produces processors are AMD and Cyrix. They have also produced x86 compatible processors, while Linux is capable of supporting processors back to the i386 generation. Many distributions, especially the ones that features corporate support such as the SUSE or Red Hat and Canonical, they limit their support to an iX86 or later. The x86-64 family of processors, including the 64-bit from the Intel and AMD, have been in production since around the year 2000, and as a result, almost all of the modern processors shipped today are the x86 64 type. So, to see which family the CPU of the current system belong to use, you may use the R command. So, like in here, I've typed R command. So, like in this case, in this case of the Linux system, the processor it has is x86 64. That's the type of the processor, the specs of the processor it has. A much more detailed one is you may type ls CPU, be able to see the width of the processor in terms of bits, the byte order, uh, and among other details. The motherboard typically has slots where random access memory can be connected to the system. The 32-bit architecture systems can use up to 4 gigabytes of RAM, while 64-bit architecture are capable of addressing and using far more RAM. So in some cases, the RAM a system has might not be enough to handle all of the operating system requirements. Once invoked, programs are loaded in RAM along with any data they need to store, while instructions are sent to the processor when they execute. And when the system is running low on RAM, virtualized memory called swap space is used to temporarily store data to disk, and data stored in RAM that has not been used recently is moved over to the section of the hard drive. We call this as virtual memory. Um, and to view the amount of RAM in your system, including the swap space, execute the free command. And the free command should have a -m option to force the output to be rounded to the nearest megabyte. And a -g option also, which will force the output to be rounded to the nearest gigabyte. So like I have here an output, this one. So free -m. So the total capacity is in this, and this is in bytes. Okay. Sorry. There's a -m, so this is already in uh, megabytes. Okay. This is in megabytes. This is the used memory space, and then this is the free space. A bus is a high-speed connection that allows communication between computers or the component inside the computer. The motherboard has buses to allow for multiple devices to connect to the system, including the PCI or peripheral component interconnect, and the most popular type of a bus, which is the USB, Universal Serial Bus. So the motherboard also has connectors for monitors, keyboards, and mouse. Different system types will use a bus differently to connect components. So like in a desktop or server computer, there is a motherboard with the processors and the RAM and other components directly attached, and then a high speed that allows additional components to be attached via the card slot, such as video, network, and other peripheral devices. Increasingly for laptop and light, small from form factor computers, the majority of the computer's component may be directly connected to the motherboard, including the usual processor, the RAM, as well as additional components like the network card. And in this configuration, the bus will exist, but effectively one of the main convenience factor of being able to swap out or upgrade devices is no longer a possibility. Peripheral devices are components connected to a computer that allow input, output, or data storage, like keyboard, mice, monitor, printers, and hard disks. They are all considered peripherals and are accessed by the system in order to perform functions outside of the central processing. So to view all of the devices connected to the PCI, the user can execute the ls PCI. And if you want to view this one, so if you want to view the output connected to the USB, you may type LSUSB. So that's it. Hard drives, also called as hard disks, these devices or storage devices, may be attached to the system in a number of ways. The controller may be integrated into the motherboard on a PCI card or a USB device. For the purpose of most Linux system, a hard drive can generally be defined as any electromechanical or electronic storage device that holds data to be accessed by the system. Hard drives are divided into one or more partition. A partition is a logical division of a hard drive designed to take large amount of available storage space and break it up into smaller areas. While it is common on Microsoft Windows to have a single partition on each hard drive, on Linux distribution, multiple partitions per hard drive is common. Some hard drives make use of a partitioning technology called master boot record, while others make use of a partitioning type called GUID partitioning table or GPT. The MBR or master boot record type of partitioning has been used since the early days of the personal computer, and the GPT has been available since the year 2000. An old term used to describe an internal hard disk is a fixed disk, as the disk is fixed or it is not removable, and this term gives rise to several command names such as the F disk, or the CF disk, and the uh, FS, SF disk commands, which are tools for working with the MBR partition disks. The GPT disks, a newer type of partitioning, which allows the user to divide the disk into more partitions than what MBR supports. GPT also allows having partitions which can be larger than 2 terabytes, which the MBR does not. So the tools for managing the GPT disks are named similarly to their F-disk counterpart, which are G-disk, CG disk, and the SG disk. So there is also a family of tools that attempt to support both MBR and GPT type disks. And this set of tools includes the parted command and the graphical G parted tool. Solid-state disks are essentially larger capacity USB thumb drives in construction and function, as there are no moving parts and no spinning disks, just memory locations to be read by the controller. A solid-state disk is measurably and visibly faster in accessing the information stored in its memory chip. A solid-state disk is controlled by an embedded or onboard processor that makes the decision as to where and how data is written and read back from the memory chips when requested. So advantages of a solid-state disk include low power usage, time saving in system booting, faster program loads, and less heat and vibration from no moving parts. Disadvantages include higher costs in comparison to spinning hard disks, lower capacity due to the higher cost, and if soldered directly on the motherboard mainboard, no ability to upgrade by swapping out the drive. Optical drives, often referred to as CD-ROM, DVD, or Blu-rays, are removable storage media. While some devices used with optical discs are read-only, others are capable of burning discs when using a writable type of discs. There are various standards for writable and rewritable discs, such as CDR, CD plus R, DVD plus RW, and DVD RW. Where these removable disks are mounted in the file system is an important consideration for a Linux administrator. Most modern distributions often mount the disk under the slash media folder, while older distribution type typically mounts them under the slash MNT folder. For example, a USB thumb drive might be mounted on the slash media slash USB thumb path. Linux, by nature, has a number of distributions or versions, a large portion of which are focused on mainstream hardware, while others run on relatively obscure types of models or of hardware. It's safe to say that there is a Linux distribution specifically designed for just about all modern hardware platforms, and for many historical platforms as well. Each of these hardware platforms has a great deal of variety in the components that are available. In addition to several different types of hard drives, there are many different graphic cards, monitors, and printers. With the popularity of USB devices such as USB storage devices, cameras, and mobile phones, the number of available devices you would want to connect to a Linux system can number in the thousands. The sheer number of different devices poses problems as these hardware devices typically needs drivers, software that allows them to communicate with the installed operating system. The driver could be compiled as part of the Linux kernel, loaded into the kernel as a module, or loaded by a user command or application. External devices like scanners and printers typically have their drivers loaded by an application, and these drivers, in turn, communicate through the device via the kernel through an interface such as a USB. Hardware manufacturers often provide this software, but typically for Microsoft Windows, not for Linux. This has been changing with the increasing popularity of Linux overall, but the desktop market share of Linux remains a very distant third to Microsoft and Apple systems. In order to be successful in enabling devices in Linux, it is best to check the Linux distribution to see if the device is certified to work with that distribution. Commercial distributions like Red Hat and SUSE have web pages dedicated to listing hardware that is certified or approved to work with their software. In order to display output to the monitor, the computer system must have a video display device and a monitor. Video display devices are often directly built into or attached to the motherboard, although they can also be connected through the PCI bus slots on the motherboard. With the large array of video device vendors, each vendor display device usually requires a proprietary driver provided by the vendor. All drivers, but most especially video device drivers, must be written for the specific operating system, something that is commonly done for Microsoft Windows, but not always for Linux. Fortunately, most of the larger video display vendors now provide at least some level of Linux support. The Linux common community has done an incredible amount of work developing standard drivers for video cards. There are three types of video cables commonly used: the older but still used analog 15-pin video graphics array cable, and the more recent 29-pin digital visual interface, and the very widely used high-definition multimedia interface, which supports resolution up to the 4K or Ultra HD range. Power supplies are devices that convert alternating current into direct current, say from 120 volts to or 240 volts up to 3.3 or a 5 or a 12 volts. So power supplies are generally not programmable. However, their proper function has a major impact on the rest of the system. Desktop, server tower, rack, and standalone systems are more vulnerable to power fluctuations than laptop systems are. If the power fluctuates, it can cause much havoc or danger on the non-battery based systems, whereas a laptop simply keeps pulling power from its internal battery until depleted. And this ends this chapter. I'd like to thank you for listening.